This problem is about shape and hybridization. Please read the problem, propose a plan to solve the problem, use this plan to solve the problem, and after that, compare your answers with the ones that I will be presenting shortly. The plan to solve this problem will be: first, we're going to have to draw the Lewis structure for the ion of interest, BrO3-, and determine the number of electron groups to determine the molecular shape denomination. Then we're going to use this information to determine the number of sigma bonds and determine the hybridization type that we have for this particular ion. We're going to also draw the molecular shape, paying attention to the groups, because the groups are going to be indicative of the repulsion that happens between the different electron groups and the angles of relevance. So let's begin then by counting the number of valence electrons looking at the periodic table. So for BrO3-, we are going to expect to have the following number of valence electrons. We have 7 for bromine, and then we have 3 oxygens. Each oxygen has 6 electrons, and we have 1 extra electron for the negative charge. So we have a total of 26 electrons. For sigma bonding, or single bonds, we are going to have 3, 2 electrons per bond, a total of 6 electrons. Remaining electrons that are non-bonding will be 26 minus 6, which is 20 electrons. So if we draw the Lewis structure for this compound, then we're going to have bromine in the middle, and then we're going to have oxygen, 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 and we are going to have to add 20 electrons to this particular molecular structure. So we are going to have 6 on each oxygen, that's 18, and we are going to have 2 additional ones on bromine, and since this is a negative ion, we are going to enclose the entire structure in brackets and put the negative sign. So because of this particular, so based on this Lewis structure, then we know that we're going to have a molecular shape of the type AX3E1. And this particular shape is called Trigonal Pyramidal. Because we have 3 bonding group of electrons, we know that the central atom bromine has an sp3 hybridized orbitals. So for this type of configuration, we know that the ideal angle should be 109 degrees when all groups are equivalent, but because we have the electron pair repulsion in the E group, the deviations that we predict are going to be that the angles are going to be less than 109.5 degrees. And this, in summary then, we went from the Lewis structure to the molecular shape, and then we used that to determine the hybridization status, and then we used that to predict the ideal angles, and then considering the electron repulsion, we went to the deviations that are expected from that.